Alright, geometry, this is our first digital lesson, and we're going to do something that is a review for a lot of you. It's been a while since you've seen area. So if you feel like you're a pro at area formulas, you may not even need to review this video. You can go ahead and practice the questions below and go ahead and see how you did. If you have any questions as far as what to do, come back and look at this video and watch it all the way through. If you still have questions, I'm going to have tutoring times posted on Google Classroom, a Zoom meeting throughout the week. I think there's at least 3, and those may change too depending upon the need of geometry versus algebra 2. I might have one just for geometry, one just for algebra 2. But you can contact me, and I'm going to be at the computer at those times. But you can always contact me by email, and I'll get back to you as soon as I can. So this also is different because with the digital learning, I can't see you. So I don't know if you don't understand. So please make sure that you reach out and email me and seek understanding, because it might be a little bit before we see each other again. So please make sure that you seek for understanding versus just kind of doing the work. We're going to start off with something that you already know how to do this week. First lesson is going to be on area formulas. The second one is going to be on composite figures. So basically we're going to put 2 area formulas together and add them together. This is review from something you've already learned in middle school, and you've done it a lot. So with that, you're just learning kind of the process of how we're going to digitally learn. Okay, so area formulas. We have some special formulas that we can substitute our values in, depending upon what the shape that we're working with. So for the first one, a triangle. Whoops, hold on. There we go. So the first one is a triangle, and notice how we have the area. A represents the area, 1/2 base times height. Now we're going to start off there, and I'm going to practice a few problems with you before you guys start on your own. So when we're finding the area of a figure, first of all, area just represents the overall, here we go, basically the overall space of that 2D figure. When we're looking at a triangle, the cool thing about a triangle is that if I were to take this triangle and cut it in half, and I take that and I move it over here, notice how we now have a rectangle. Okay, but that original base is half. So if this original base was 27, if in order to find this area of a rectangle, which we already know is base times height, we're going to take 27 and we're going to divide it, and this height right here is 16. Okay. We're going to take that original length of 27 and divide it by 2. So if I take 27 and divide it by 2, we would end up with 13.5, which would be that length right here. Okay, and we would multiply those 2 together. Now our area formula for a triangle is area equals 1/2 base times height. So that's ultimately what we're doing here. Okay, we end up with the area equals 1/2, and then our base is 27 times our height, which is 16. Notice how we do not need to use the hypotenuse. In mathematics and in real life, there's always values that are extra or extraneous that you do not need. And that happens a lot. There we go. All right. So now we're going to go ahead and calculate by multiplying 1/2 times 27 times 16, just like we did up here. So it really end up being 13.5 times 16. Okay, which is going to end up being our area equals 216 centimeters squared. All right. Okay, let's go ahead and take a look at our second example. Now the reason why I showed you this example is because notice how our height is now in the exterior of our triangle itself. It's no longer on the inside of the triangle, and that is okay. The one thing we do not need is this length right here, because we want the height perpendicular to the base. Now, when you go to the doctor's office, I always tell my students that when you are trying to find your height, you're not trying to stand sideways to the doctor to try to figure out how tall you are. Okay, but you're standing straight up. In fact, you might be like tiptoeing just to try to get a little inch or two in. Okay, so you're going to go ahead and take area equals 1/2 base times height, which is going to be 20.4 times 14.6. You're going to multiply all of that together. Hopefully your calculator on your cell phone works well, or if you have a calculator, go ahead and use it. Okay, and I'm going to round to the nearest hundredth on this one. Okay, and that's going to be inches squared. Always squared because you're really multiplying dimensions together. So inches times inches would give you inches squared. Now our next one we're going to talk about is rectangles and squares. Now I put this one together so that because with the rectangle it's just area equals base times height. I'm going to give you this formula sheet also, and this is perimeter. But what we're working on today is just area, and with a square and a rectangle, they're the same except for a square is the same size, same sides. So we're going to end up with, if this was 5 and that was 5, it would just be 25 for the area of the square. Okay, so for rectangle, we would end up with the area equals 11.8 times 16.4 feet, and when we multiply that out, that would give us the area equals 193.52 feet squared. Always have your units on there. That's going to be very important next year for physics. Okay, so let's go ahead and take a look at this problem. So here we have our square, all sides are the same, we have 90-degree angles. The area for this is just going to end up being area equals 17.6 squared. So the overall area for the square would end up being 309.76 millimeters squared. All right. Parallelograms. So remember with parallelograms, we have opposite sides are parallel. And that also means that we have special properties with a parallelogram. It was within our quadrilaterals unit. Okay, and the cool thing about a parallelogram, and normally in class I would take an actual construction paper and I would show you guys this. But if I go ahead and take this triangle right here, notice how the height perpendicular to the base creates a right triangle. If I were to take that and cut it off and I moved it over here and glued it or taped it, okay, I would end up with, and I'm going to change color. Whoops. Here we go. If I take that triangle and cut it and move it over to the other side, I would end up with a rectangle. Now with this rectangle, notice how our dimensions, our opposite sides are congruent. We would just end up finding the area of a rectangle, which we already know is the area equals base times height. And that's why when you look at a parallelogram formula, we would end up with the same formula as we would with a rectangle. Okay, because if we were to take that triangle, move it over, we would end up with a rectangular shape. So our area is just going to end up being 21 times 33. Overall area is 693 meters squared. Okay, so let's look at this other parallelogram. Now notice how we have way more information than we need, and that's okay. What you need to remember with the area of a parallelogram is that if we're looking for base and height, remember the height is always perpendicular to your base. So if you find your height, which comes with that 90-degree angle, we know that this is going to end up being height, and then perpendicular to the base, this is the number I care about. This is going to be your base, or down here. Okay, your base isn't always going to be on the bottom of the shape. Okay, so I don't care about this 10 yards. What's going to happen is I'm just going to end up with area equals 19 times 7.8. Okay, now 19 times 7.8, that's just going to give us area equals 148.2 yards squared. Now we're going to go ahead and take a look at the area of a trapezoid. So when we're looking at area of a trapezoid, the cool thing about trapezoids are that if we ultimately take kind of a diagonal from one corner to the other, do you notice we have two triangles here? Which is pretty cool. So what we would end up with is we would find the area of this triangle, which would be 15 times 7, and we'd also have 11 times 7 and add those two together. Now our formula, though, is essentially that. We're going to end up finding the 1/2 times height times base 1 plus base 2. Okay, so that formula already calculates basically the area of those two triangles if we were to break apart the trapezoid. So I'm going to erase these guide marks here. Okay, and we're going to start off with, hold on. We'll start off with the area equals 1/2 base, not base, the height times base 1 plus base 2. Okay, so area is going to equal 1/2. Our height is always perpendicular to our base. Now the bases, they're special because we're looking for the parallel bases. Okay, so the two parallel bases, we have base 1 and base 2, and here's our height. So our height is 7 times base 1, which is going to end up being 11 plus 15. Okay, add that together, that's going to give us 26 times 7 times 1/2. All of that multiplied together gives us 91 inches squared. And that's going to be the area of this trapezoid, the 2D space in between. Now let's go ahead and take a look at this trapezoid. Extra information. Okay, but always look for the bases that are parallel to each other, which is 13 and 38. We do not need those two. This is kind of cool. It's actually an isosceles trapezoid. But anyway, so we're looking at the area equals 1/2. Our height is always perpendicular to our base. Okay, so that's going to end up being 32.7 times 38 plus 13. Okay, finishing up the trapezoid, after you multiply all of that out, we would be left with 833.85 meters squared. Now let's go ahead and take a look at circles and semicircles. So when we have a formula for, our formula for area of a circle is area equals pi r squared. We do need the radius. So from the inside out, that's going to be our radius. And remember, if it is a chord that goes from one side of the circle and passes through the center, that's going to be called our diameter. And we're lucky. This case we have our radius, which is going to end up just being pi times 2.9 squared. After multiplying all of that out, you should end up with the answer of area equals 26.42 feet squared. Now, on this one, we're looking for only half of a circle. So if it's only half of a circle, we're really taking our area formula for a circle, area equals pi r squared, and dividing it by 2. So our area in this case is going to end up being pi, and then the radius is, in this case, we are given the diameter equals 44. We just need the radius, which is half of that. So that's going to give us 22 inches squared, all divided by 2. Remember, order of operations states that we need to go ahead and square this 22 before we divide by 2. So it's going to be 22 squared times pi, which is approximately 3.14, all divided by 2, which is going to give us 760.27 inches squared. All right, that concludes our area formula lesson. I hope you guys are all doing well. If you need extra practice, please come talk to me during the tutoring time. There's a Zoom session at 11 today. There's also going to be other Zoom sessions over the course of the week. It's not mandatory that you do that. I hope you guys are staying well, helping out your families. Have a wonderful day, and enjoy the rest of your week. Thank you.